Okay. Good afternoon to one and all. So, in the previous lecture of electrical machine first, we have discussed regarding types of transformer. In case of types of transformer, we have discussed different types of transformer. In that, according to construction of transformer, there is a two types. First one is nothing but core type transformer, and second one is nothing but cell type transformer. Then according to phasing, we have discussed regarding two types of transformer, that is single phase transformer and three phase transformer. Again, according to voltage level, we have defined two types of transformer, that is step up transformer and step down transformer. Okay. Again, according to application, we have discussed regarding power transformer and distribution transformer. Power transformer and distribution transformer also we have discussed. Again, according to the that means measuring instrument, we have discussed two types of transformer, that is first one it is nothing but CT, that is current transformer, and second one nothing but potential transformer. Okay, now see, today we will discuss about the next one point, is that the transformer on no load condition and transformer on load condition with phasor diagram. Okay, so transformer, what will happen when the transformer it should be putted on no load condition, and what will happen when the transformer it will put it on no load condition? Can anyone tell me why it is necessary to understand the condition of no load and on full load condition? Anyone? Why it is necessary to understand this condition, that is no load condition of the transformer and full load condition of the transformer? Can anyone? Yes. Okay, we want to perform the practical of the same also. It's a practical पर perform करायचे, that is no load test and full load test. Who is given answer, that is core loss can be calculated. Okay, right. That means see, from performing a no load and from performing a full load, what is the condition to understand the no load and full load? That means why we are taking these two terms, that is no load and full load. That means sometimes transformer it may be on no load, sometimes transformer it may be on full load. म्हणजे काही वेळासाठी ट्रान्सफॉर्मर नो लोडला पण असू शकतो, काही वेळासाठी तो फुल लोडला पण असू शकतो, राईट? बरोबर? हॅलो?
Yes, sir.
Okay. See, suppose we are considering any one of the distribution transformer. एखादा डिस्ट्रीब्युशन ट्रान्सफॉर्मर कन्सिडर केला आपण. सपोज एक ट्रान्सफॉर्मर आहे असं कन्सिडर करा, and power fed by this transformer, it is nothing but, suppose this transformer it will be fed power to the one three phase pump, only for three phase pump. I am discussing regarding that. Okay, only for three phase pump or agriculture field, only for three phase pump. Okay, see, when in the rainy season, suppose consider in the rainy season, whether there is a pump on that transformer, it is on running condition or not?
Off condition.
Off condition. Okay, so pump on that season, or it may be at that time, pump which are connected on that transformer is at off condition. So pump is at off condition, whether there is a load in the transformer or not?
No load condition.
Okay, no load condition. That means, so see, sometimes load it may be present, or sometimes load it may be not present. Sometimes load it may be a full load condition, sometimes load it may be a half load condition, sometimes load it may be a minimum load. Okay, so that we want to understand the behavior of the transformer at these two condition, that is at load condition and at no load condition, so that it is purposefully these 2 points it can be shown here. That is, we want to understand the behavior, or we want to calculate the sum of the losses by conducting these types of tests, that is no load and full load. So what will happen, or the transformer it will give what type of performance when it is on no load, transformer it will give what type of performance when it is on load. लोड वरती असल्यानंतर काय त्याचा परफॉर्मन्स येतो, नो लोड वरती असल्यानंतर काय त्याचा परफॉर्मन्स येतो. सो इट शुड नो टू द डिझायनर so that it will able to design very much efficient or it may be very good transformer. So that in the designer point of view or in the designer, it should be know that when at the no load condition and at the full load condition or it may be load condition, we want to understand the behavior, right? So that we are taking the today's point, that is no load, that is transformer on no load condition and transformer on load condition and with their phasor diagram, right? Now see, suppose if we are taking one transformer, it will be fed to that of any village. So at that situation there are three phase load also, single phase load also. Okay, so see, in case of that type of transformer, if three phase and single phase load is there, so even though on that transformer there is a single phase load should be present, but sometimes the single phase load should be at off condition, right? No, asto ka? Single phase load, it is also at off condition for a some time. I am telling within 24 hours for a some time, that means for 1 hour, for 2 hours, or it may be for up to 4 hours. There is a no load on the transformer. So designer should be know, or designer should be understand, while constructing any one of the transformer, it should know the behavior of the transformer. That is what it will be give the behavior on no load condition. So then what is the behavior of the transformer at load condition, right? Okay, now we will discuss these 2 points. First of all, we will discuss the no load condition. Next we will discuss the load condition. What is the advantages of load condition, no load condition, we will discuss one by one. Now see, see here, when the transformer it is on no load condition, we will first discuss first one point, that is transformer it is on no load condition, right? Transformer on a no load and no load condition with their phasor diagram. See, a transformer it is said to be no load. Okay, what is mean by no load? Here the load should be 0. I will show the diagram. What is mean by no load?
Secondary winding open circuit.
Okay, that means secondary there is a no load, so it is nothing but secondary side it is open circuited, right? So secondary side it is open circuited. How much current it will be flowing from secondary side?
0.
That means
0.
at no load condition there is a 0 current, it will be flowing from secondary side, but there is a somewhat voltage induced EMF it should be present, right? No load condition la kaitari induced EMF काय असेल present असेल. See, the no load it is nothing but the transformer it is on no load, that means its secondary winding it is open circuited. See, here it is transformer, this one is the primary winding of the transformer, this one is the secondary winding of the transformer. On the primary side there is a some of the that means it is connected to supply voltage, it is connected to supply voltage, or some voltage it should be applied to that of primary winding. There is a secondary winding, and the secondary side of the transformer it should be open circuited, then we can call it as a no load condition of the transformer. So in while performing practical, we can call it as a OC and SC test, that is open circuit test, that means secondary it can be open circuited, and short circuit test it is nothing but short circuited secondary, म्हणजे secondary side मधून short circuit केले current flow, right? See, a transformer it is said to be no load when its secondary side winding it is open circuited. ज्या वेळेस त्याची secondary side ची winding काय आहे, open circuited आहे, at that situation we can call it as a this transformer it is at no load condition, or there is a no current flowing from that secondary side. So see, secondary side is open circuited, meaning of that there should be a no load it can be attached on that transformer on the secondary side. Secondary side la load attached केलेला नाहीये. So if there is a no load, that means current flowing from this secondary side it is equals to 0, or no current it will be flowing from secondary side. Okay, do you know that some losses of the transformer, it will be depends on the current. Current वरती काहीतरी losses depends असतात. Can anyone tell me the which losses it should be depends upon value of current? Which loss? We have already discussed in case of generator and motor.
Copper.
Copper loss.
Copper loss. So copper loss, it should be depends upon current, value of the current. If there are no current flowing from secondary side, whether there is a copper loss, it will be present on the secondary side.
No, sir.
That means there is a no copper losses, it should be present on the secondary side. Also, there is a no load on the transformer. Transformer or the load nahiye, so that current taken from the supply, whether it is more or less, supply कडून घेतलेला current more असेल का कमी असेल at a no load condition. क्वेश्चन माझा लक्षात आलाय का? There is a no load on the secondary side, म्हणजे तो लोड फुलफिल करण्यासाठी आपल्याला करंट पाहिजे, but there is a no load on the secondary side. Whether somewhat current it should be taken from the supply or more current it will be taken from the supply. सप्लाय कडून घेतलेला करंट कमी असेल की मॅक्झिमम असेल, जास्त असेल? कमी असेल ना. सपोज इन केस ऑफ मोटर यू कन्सिडर इफ द लोड increases, what happen? Torque requirement is increases. To meet that torque value, the current taken from the supply, it will be increases. Similar to that, there is a no load, that means secondary side, या secondary side मधून फ्लो होणारा करंट 0 आहे. That is I, it is equals to 0. Current flowing from the secondary side, it is equals to 0. So there is a no load. Current taken from the supply, it is minimum, or this current taken from the supply is only to overcome the no load losses. जेवढे no load losses असतील तेवढेच ओव्हरकम करण्यासाठी करंट रिक्वायर्ड आहे. ओके. अगेन in case of no load losses, in case of transformer, there is a no any rotating part, so there are no friction and windage losses. Whether there is a friction and windage losses is there? No load loss मध्ये असतील का? Hello.
No, sir.
Do you know that in case of motor or generator, we have discussed regarding losses. That is losses. One we can call it as a constant loss. One we can call it as a variable loss. Variable loss in the sense it will depends upon the value of current. That is load current. Okay. And constant losses, it should be depends upon its manufacturing parameter. That is magnetic property of the parameter. So there is a no load, so that variable losses it should not be present. Constant losses, in case of motor or generator, there are some types of constant losses like iron and friction loss. So windage losses, stray losses, because there are some rotating part आहे त्याच्यामध्ये, so that there are friction and windage losses will be there. Stray losses, it is also depends upon rotation, and windage losses is there. So in case of transformer, in constant loss, only two types of losses are there, that is iron loss. In that iron loss, we can call it as a eddy current loss and hysteresis losses. So only these two losses, because there is a no rotating part in case of transformer. See, these losses, to overcome the value of these losses, just minimum amount of current it is required. So that minimum amount of current it will be taken from the supply. Supply कडून हा कमी amount चा current काय केला जाईल, घेतला जाईल. So see, when secondary it is no load condition, that means there is a zero current flowing from secondary side or zero load. When an AC sinusoidal supply is connected to the primary winding of the transformer, a small current, that is I open circuited current, will flow through the primary coil, or it may be primary winding, due to presence of the primary supply voltage. Primary ला आपण काय करतोय, supply voltage देतोय. Due to that supply voltage, there are some of the small amount of current, that is we can call it as a no load current, or it may be I open circuited current. It will be flowing from primary winding. Okay. Now, when the current flowing from any coil, what will happen? एखाद्या coil मधून current flow झाला, काय होतं? Hello. If the current flowing from any winding or coil, what will happen first effect?
EMF produce.
Directly EMF, not flux. Into flux, it will be produces. That means magnetic field it will be created. Okay. Due to that magnetic field, the EMF it should be indices in that primary winding. So this magnetic flux, again this magnetic flux created, that is phi. Due to that value of flux phi, this flux phi according to mutual induction principle it will be linked to that of secondary, because there is a magnetic coupling between primary and secondary. Primary and secondary च्या मध्ये magnetic coupling आहे. So that due to the magnetic coupling between primary winding and secondary winding, on the secondary side of the transformer there is some EMF it will be induces, but the secondary circuit it is open circuited. So that means there is no current flowing from secondary side. Secondary side मधून current flow होणार नाहीये. That is on a no load condition. So this condition it is nothing but transformer on no load condition. Okay. See when the secondary circuit it is open, that means nothing it can be connected to the secondary side. A back EMF along with the primary winding, resistance, it will be acts to limit the flow of this primary current. Okay. हा जो काही इंड्यूस होणारा EMF आहे, so there is no any terminal connected, or it may be no any link connected in between these two terminal, that is open circuited terminal. So this EMF, that is it will act as a back and it will oppose to this current taken from the supply. Supply कडून घेतलेला current ला काय करेल? Oppose करेल. Obviously this no load primary current I0 must be sufficient to maintain the enough magnetic field to produce the required back EMF in that circuit. Okay. हा जो काय primary कडून घेतलेला current असेल, so this current it is just sufficient. This current it is just sufficient to fulfill or to maintain the EMF induced in the primary and secondary. Primary मध्ये induce होणारा EMF, and when it is linked to that of secondary, secondary मध्ये induce होणारा EMF. So to sufficient maintain this enough magnetic field, it will take a small amount of current. Okay. See, to measure that value of current, here it is one ammeter it can be connected. त्या current ची value measure करण्यासाठी आपण काय केले? Ammeter it can be connected here. One of the ammeter it can be connected here. So this similar construction it can be done, or it may be similar connection it can be done while performing the practical on no load condition. No load condition चं practical perform करताना आपल्याला काय करायचंय हे विचारात घ्यायचंय. See, this ammeter it will be read the no load value. This ammeter it will be reads the no load current taken from the supply. Supply कडून घेतलेला जो काही no load current असेल, it will be denoted by this ammeter, or ammeter it will be shows the no load current taken from the supply. Okay. Now this current it will be taken from the supply to overcome the no load losses, or the function of this component or function of the current. It will be divided into two components. तो दोन component मध्ये काय होतो? Divide होतो. See, the ammeter above will indicate a small current flowing through the primary winding, even though the secondary circuit it is open circuited. जरी secondary circuit open circuited असेल, if the secondary circuit it is also open circuited, okay, it is also open circuited, then there is some primary current taken from the supply. So it will be shown by no load current or I open, that is I0 or no load current, I0 or the no load current taken from the supply. Okay. Now this no load primary current it is made up of the following two components. आता हा जो काय primary current असेल, so this primary current it is divided into two components, or it is made up of a two component. दोन component चा काय केलेला तो made झाला. So first one component is that an in phase current IE which supplies the core loss, that is iron and core loss, that is eddy current loss and hysteresis loss. Okay. हा जो काय current असेल, it will made up of two component. I will show it in the phasor diagram मध्ये मी ते दाखवतो तुम्हाला. Just 1 minute. Okay. See, this no load current, that is current taken from the supply, it will be divided into two components. One component, it is in phase current, that means it is in phase with that current, that is IE, which used to produce or which used to supply or overcome the losses. The losses are, that is eddy current loss and hysteresis loss. And a small amount of current, that is IM. So we can call this one is nothing but two component. One component is nothing but magnetizing component and one component is nothing but working component. Okay. So a component मी सांगतो तुम्हाला, but see, a small amount of current IM at a 90 degree to the voltage which set up in the magnetic field. That means there are two components. It will be produces by this no load current, or the no load current, it is made up of these two components. या दोन components तो no load current बनलेला असेल. So first component, it is along with a phase current, along with the phase current. So along with phase current is nothing but it is used to provide the it is used to overcome the no load losses. It is used to overcome the no load losses. And the second component is that we can call it as a magnetizing component, which is perpendicular to that of supply voltage, or it is 90 degree to the voltage which set up the magnetic field. Magnetic field ला set up करणारा जे काय voltage आहे त्याला 90 degree असेल. Okay, see, I will show the phasor diagram now. How the phasor diagram it will be drawn, how the phasor diagram it will be drawn, this will also I am explaining. Okay, so this is the phasor diagram of no load condition. When the transformer is on no load condition, this is the phasor diagram. So while drawing the phasor diagram, consider a flux phi be the reference phasor. Okay, consider the flux phi, it is nothing but a reference phasor. Okay, if the flux phi it is reference phasor, if the flux phi it is nothing but it is the reference phasor, then we want to derive the no load current taken from the supply. Okay, no load current taken from the supply. Okay, see, even if the transformer is on no load condition, jari transformer no load condition la असेल, it will take some amount of current from the supply, but this supply current, it is not totally reactive. What I am telling, all of you understood, that is supply current taken from the supply, it is not wholly or it is not totally reactive. So the primary input current under no load condition, it is used to supply these two components. First one is nothing but iron and core losses, and the second one component, it is nothing but it is out of phase, or it is 90 degree from that of supply voltage. So this is required to small amount of copper losses, it should be present in the primary winding. I am not telling about secondary winding. So current flow होतो एखाद्या winding मधून, winding it is having an some of the resistance. Okay, see, एखाद्या वाइंडिंग मधून आपण मोटर मध्ये किंवा जनरेटर मध्ये बघितलं बघा, ऑलरेडी वी हॅव डिस्कस. सपोज दिस इज वन ऑफ द वाइंडिंग having an resistance of 0.1 or 0.5 ohm. If the current flowing from this winding, whether there is copper loss, it should be present on that winding. Copper loss present असतात का? Hello, all of you understood my question? Any one of the winding it is there, and this winding it is having and some of the resistance. आपण शंट मोटर, सिरीज मोटर, सो आपण टेस्टिंग मधले प्रॉब्लेम पण सॉल्व केलेले आहेत. सो दिस वाइंडिंग हॅव्हिंग अँड सम ऑफ द रेजिस्टन्स, अँड व्हेन द करंट फ्लोइंग फ्रॉम दिस वाइंडिंग, या वाइंडिंग मधून करंट फ्लो होतोय. सपोज 10 एम्पियर करंट इट विल बी फ्लोइंग फ्रॉम दॅट वाइंडिंग having an resistance of 0.1 ohm. Whether there is a copper loss, it should be present.
Yes, sir.
That means copper loss it should be present. So current it will be start flowing from only primary or secondary, or both? Primary winding मधून current flow होतोय का?
Yes, sir.
Current flowing from primary winding, but secondary winding मधून होतोय का? There is open circuited, no current flowing from secondary side. So secondary side copper losses it is 0, or copper losses it will be not present in the secondary side. But due to that small current in the primary, there is some copper loss, it should be present in the primary winding. असतील का? Primary winding मध्ये काही copper loss present असतील का?
Yes, sir.
Yes. So that means to overcome these losses, one current, that means I am telling no load current, it will be divided into two components. One component or one current it is used to overcome the iron loss and all other losses like eddy current and hysteresis loss, and another component it is in 90-degree phase with that of supply voltage, but it is used, or it is component of that no load current, that is it is used to overcome the copper losses which are present in the primary winding. Only primary winding मध्ये present असणारे copper loss. Okay, see, hence there is a no load primary input current I0. This current I0 it is not exactly 90-degree because some of the reactive part it will be present. Okay, so that means see here, this no load current it is not exactly 90-degree because for pure resistance or pure resistive असेल, for pure inductive, what is the current and voltage relation? Current आणि voltage relation काय असतं? ही जी काही कॉइल आहे, whether it is inductive coil or resistive coil?
Inductive.
Inductive coil. So inductive is nothing but there is a we can consider inductive load, or it may be inductive coil, whether there is a lagging power factor or leading power factor. That means current lag behind by voltage, or current lead behind by voltage, current leads the voltage, current lag the voltage. Okay, if it is purely resistive, if it is purely reactive, जर ती purely reactive असेल तर as per the condition, if it is not wholly reactive, so that I am telling, if it is wholly reactive, then the current should be exactly 90-degree lag behind by voltage, right? बघा, जर रेजिस्टिव्ह असेल तर करंट आणि व्होल्टेज इन फेज मध्ये असतं. जर रिएक्टिव्ह असेल, that means inductive or reactive, we can call it as a, that means here it is inductive reactance we can call. Totally reactive असेल तर current it will be lag 90-degree behind by voltage. बरोबर ना?
Yes, sir.
Exactly 90-degree. And if it is capacitive, so capacitive असेल तर current जो आहे, that is I, it will be leads exactly 90-degree by voltage. Okay, see, due to this winding it is not wholly reactive, or this current taken from the supply it is not totally reactive. So no load current taken from the supply it is नॉट एक्झॅक्टली लॅग 90 डिग्री बिहाइंड बाय व्होल्टेज. व्होल्टेजच्या एक्झॅक्टली 90 डिग्रीने तो काय होत नाही, लॅग होत नाही, बट इट विल लॅग समवॉट लेस अँगल दॅन 90 डिग्री. 90 डिग्री पेक्षा काहीतरी कमी अँगल न तो काय होईल, लॅग होईल. राईट. सो ऑल ऑफ यू अंडरस्टूड दिस पॉइंट. लक्षात आला का हा पॉइंट? Why this current it will be I0, it will be come here. I will tell how this diagram it will be drawn. Hello. Yes, give me reply fast. Okay, see here, हा जो काय I0 होता, that means current taken from the supply, that is I0. If it is totally reactive, then it should be exactly 90 degree. म्हणजे हा जो काय I0 इथं येण्यापेक्षा तो इथं यायला पाहिजे होता. Right. So see, but it will be less than that of 90 degree. 90 डिग्री पेक्षा काय होतोय, तो लेस अँगल न लॅग होतोय बाय व्होल्टेज. सी हियर, देयर इज अ व्होल्टेज V is given, that is primary supply voltage VP, and here a no load current I0 taken at the no load condition. Okay, so it will lag behind by voltage by some angle, so we can represent this angle is nothing but phi0. हा phi0 angle काय केला आपण, रिप्रेझेंट केला. So it will be lag behind by voltage by a phi0 angle. So always keep in mind this phi0 angle, it is always less than that of 90 degree in case of practical transformer. In case of ideal transformer, it is nearly equal to that of 90 degree. Right. See, note that this no load primary current I0, it is very small as compared to that of full load current. Suppose transformer, it is having an rating of 10 ampere. Transformer's rating जर 10 ampere असेल, so near about 1% or near about 2% current it will be taken from the supply at a no load condition. That means it is very less current, or it will be a very less current as compared to that of full load current. Full load current ला compare करता हा जो काय current असेल, it is very less. Okay, so also due to the iron loss present in the core as well as small amount of copper loss in the primary winding. So we are neglecting the value of copper loss. Copper loss ची value आपण neglect करणार. So we calling it as a from no load condition or from no load test, we are able to calculate the only constant losses or the core loss, or we can call it as a iron loss. आपण फक्त iron loss or constant losses काय करू शकतो, calculate करू शकतो. Now see how this phasor diagram it will be calculated, or how this phasor diagram it will be drawn. Consider the flux phi is the reference phasor. Okay, flux phi it is the reference phasor. ही phasor diagram draw करतोय मी. So consider this flux phi, it is nothing but reference phasor. Now this phi, it is nothing but reference phasor. Do you know that this flux phi, when this flux phi it will be produces, कधी प्रोड्यूस होतील फ्लक्स phi? Current flow झाला. That means the current taken from the supply, or it is depends upon current. That means you consider this is the value of current. We are taken this phi is nothing but flux is nothing but reference phasor, and we are applying the supply voltage VP. Here it is sentence is given VP by exactly 90 degree. Okay, that means we are applying supply voltage here, VP is here, that is primary supply voltage VP. Okay, primary supply voltage VP. We know that the no load current taken from the supply, it will be divided into two components, or it is made up of two components. One component it is in phase, one component it is in phase with that of voltage, voltage च्या phase मध्ये असेल. So see, and in phase current, that is IE. Okay, one component it is in phase with voltage, voltage च्या phase मध्ये असेल, which is used to overcome the no load losses. No load losses overcome करण्यासाठी काय केलेला आहे तो यूज केली. And one component it is exactly 90 degree apart from that of supply voltage. Okay, so see a component, so this component we can represent, it is nothing but IE na represent karto, or we can call it as a IW. बघा कुठलेही notation use करा. So this component, it is called as working component of the no load current. All of you write, or all of you keep in mind, लिहून घ्या वाटलंस तर. It is represented by IE, or it is represented by IW. So we can call it as a working component of the no load current. Working component of the no load current. And one component, so this IE component or working component, it is along with or in phase with supply voltage. Supply voltage च्या in phase मध्ये. Second component, it is nothing but we can call it as a magnetizing component. We can represent either it is IM, तो आपण IM ना represent करू शकतो, किंवा we are able to representing this is nothing but I mu. I mu ना पण represent करतो. So this component, it is a 90 degree lagging behind by VP. VP च्या 90 degree काय आहे? Lag आहे. हे लक्षात आलं दोन component, how it can be derived. See, consider a reference phasor. Consider a reference phasor of flux phi reference घेतला. It is along with that of current. It is along with that of current. That means it is in phase with current. So I want to draw the supply voltage phasor. So if ideal transformer is there, or we are considering ideal condition, then the supply voltage, it is exactly 90 degree leads by current. That means current lag by 90 degree by an voltage. Okay, that means we have derived it is VP, or primary supply voltage. Now see, there are two component. One component, it is nothing but working component, which is used to overcome the losses like iron, or it may be a hysteresis or eddy current loss. It is in a phase with voltage. Voltage चा काय असेल तो phase मध्ये असेल. Second component, it is nothing but it is called as magnetizing component. It is represented by IM, or it is represented by I mu. Okay, so this component, it is lagging behind by supply voltage by an angle 90 degree. So 90 degree ने काय आहे? Lag होते. Now see, if we draw the parallelogram of these two component, जर आपण या दोन component चा parallelogram draw केला, see here, if we draw the parallelogram, or if we extended this line, that is this working component, it will be extended to the up direction. Sorry, see here, this I mu, it is nothing but magnetizing component. It will be drawn here, and the IE is nothing but it is called as working component, this dotted line. So we have drawn here one parallelogram, or we can call it as a rectangle. Once we drawn this diagram, we got one resultant. So this resultant current, if it is drawn from the origin of the or it is drawn from the O point or the origin, then we got a no load component of the current, that is I0. No load component of the current, it is nothing but I0, and this I0, it will be lag behind by primary supply voltage by an angle, that is phi0 angle, but it is less than that of 90 degree. 90 degree पेक्षा less है ना? Hello? Yes, it is less than that of 90 degree. So it is not exactly 90 degree. Why? Because this current taken from the supply, it is not a totally inductive reactive. That means it is not a reactive, that is inductive reactance. So some of the impurities or some of the resistive component, it should be present. So it will be not exactly 90 degree. It is less than that of 90 degree. 90 degree पेक्षा काय असेल? Less असेल. So this is the phasor diagram of the this is the phasor diagram of the no load condition of the transformer. Transformer no load condition ची काय आहे? Phasor diagram आहे. Okay. Now, according to this we are deriving the value of, or we are calculating the value of I mu and IW. Once we got the value of I mu and IW, then we are able to calculate the value of no load current. Or once no load current value in your hand, then we are able to calculate the value of magnetizing component and the working component. Okay, so see, one component, it is in phase with that of supply voltage. We can call it as an active component or working component of the no load current. हा जो component आहे IE, it is in phase with that of supply voltage. तो supply voltage च्या phase मध्ये आहे. So we can call it as an active component, or we can call it as a no load component. We can call it as an active component or the working component of the no load current. No load current is a working component, and one component, it is in 90-degree lagging with that of supply voltage. Okay, so this component, it is known as magnetizing component, or we can call it as a magnetizing inrush current. Okay, so magnetizing component, it is 90-degree lagging behind by supply voltage. And if we do the addition of these two components, or if we do the vector sum of this component, then we will get the magnitude of no load current taken from the supply. So if I am writing equation, that is no load current taken from the supply कडून घेतलेला जो काही no load current असेल, that is I0, it is equals to under root of IW square plus I mu square. If you are writing not taking under root, then I0 square, it is equals to IW square plus I mu square. या दोन्हीचा काय येईल, स्क्वेअर येईल. Okay, so this is the no load component, and it is the vector sum of that is I0. जर मला I0 represent करायचा असेल, if I want to represent I0 vector, it is equals to, this is the vector sum of IW plus I mu. And if it is vector sum, if you want to take the magnitude, then do you know that I0, it is equals to under root of IW square plus I mu square. It is this equation, it is useful while calculating some problem calculate करताना हे useful आहे. So this is the IW square plus I mu square, and the angle supply voltage and no load current याच्यामधला जो काय angle असेल, that is phi0, it is nothing but no load angle. And if we represent it by using a cos of phi, then it is nothing but no load power factor, right? Then it is nothing but a no load power factor, right? So this is related to the no load component, that is no load component or no load current taken from the supply when the transformer it is at a no load condition. Also we want to we are able to determine the no load losses like iron loss and copper loss, and this is useful to designer. While designing any one of the transformer. एखादा transformer design करताना it is useful, because while designing suppose any one of the power transformer, एखादा power transformer काय करायचं मला design करायचं. Okay, do you know that the primary of that transformer always it is connected to the supply line? Connected असते का? एखादा transformer आहे, suppose एखादा power transformer आहे किंवा एखादा substation मधला transformer. So primary winding of the transformer always connected to the supply line, right? Even if there is a no load. किंवा आपला village मधला किंवा agriculture field मधला एखादा transformer consider केला. If we are considering that transformer, and if it is on load, it should be present on the transformer or not. Load present असेल किंवा नसेल, then also the primary of the transformer it is always connected to supply. त्या transformer ची primary काय राहील, supply ला always connected line. So while designing, the designer should taken into account whether that transformer primary is always connected in supply, so it will give more importance to that of iron loss. तो iron loss ला काय करेल, जास्तीत जास्त important देईल while constructing a transformer. That means it will give a less importance to that of copper loss. right? बरोबर ना? Now see, he know that he want to design any one of the transformer, and he know the load on that transformer for sometimes it may be 0. Whether there is a that means whether there is a importance to do to give importance on the copper loss, म्हणजे त्या लाईन वरती काही काळासाठी लोड नसणार आहे, मग इट इज युजफुल टू गिव्ह द इम्पॉर्टन्स ऑन द कॉपर लॉस. कॉपर लॉस ला इम्पॉर्टन्स देणं गरजेचं आहे का?
No, sir.
So that designer should think, if the transformer it is somewhat on no load condition, so it should think about iron loss. तो आयर्न लॉस चं थिंकिंग करून, म्हणजे आयर्न लॉस कशी कमी करता येतील त्याच्यावर विचार करून तो काय करेल, डिझाइन करेल. सो दिस इज द इम्पॉर्टन्स while understanding, this is the importance to understand the transformer on no load condition and their phasor diagram. So it is also very important, that is transformer is on no load condition, transformer on no load condition. And if we want to find out the value of current at a no load condition, that is I0, or if we want to find out the value of component, that is working component and magnetizing component, then also it is useful, this equation. So see, we are conducting a test. Okay, while conducting the test, we are doing same connection, and we are also one of the connecting here one wattmeter. इथे एक आपण wattmeter काय करणार, कनेक्ट करणार. ओके, एमीटरच्या पुढे एक wattmeter कनेक्ट करतोय. So to measure the input power, हा input current आहे, input power taken from the supply. Okay, what is the formula for power? If we know the power formula, P is equals to काय formula power चा in case of transformer? Yes, what is the formula for power? No load voltage V into no load current taken from the supply into cos of phi 0, right? You people get the value of V0. आपण सप्लायचं व्होल्टेज किती देणार आहे किंवा फुल सप्लाय व्होल्टेज अप्लाय करणार आहे, ती व्हॅल्यू असेल आपल्याकडे, पॉवरची व्हॅल्यू असेल. यू पीपल आर हॅव्हिंग द व्हॅल्यू ऑफ I0 ची व्हॅल्यू असेल. सो सी, इफ वी आर हॅव्हिंग दिस ऑल व्हॅल्यू, अकॉर्डिंग टू दिस वी आर एबल टू फाइंड आउट द व्हॅल्यू ऑफ cos of phi 0. cos of phi 0 ची व्हॅल्यू कॅल्क्युलेट करू शकतो. And again we are able to find out the value of working component and magnetizing component, that is Im and Iw, or we can call it as a Imu and Iw. Active component, or we can call it as a working component, and Imu is nothing but magnetizing component, or it is represented by Im. So Im na represent karo. Okay, see, according to this phasor, how it can be represented? What is Iw? Iw, it is equals to no load current I0 into cos of phi 0, and Imu is nothing but no load current I0 into sin of phi 0, right? See here, suppose this current, this phasor, this angle is nothing but phi 0. So tell me the value of sin of phi 0. Sin phi 0 ची व्हॅल्यू सांगा. This is nothing but I0, this is nothing but Iw or IE, and this is nothing but Imu. काय असतं sin theta? Sin theta, it is equals to माहिती आहे ना, मॅथमॅटिक्स झालंय तुम्हाला. This one is the one triangle having at 90 degree. That means hypothesis, opposite side, adjacent side. काय असतं sin theta? Here it is theta. Sin theta. Sin theta. Sin theta ची डेफिनेशन, opposite side divided by hypothesis, and cos theta is nothing but adjacent side divided by hypothesis. That means दॅट मीन्स विरुद्ध बाजू भागिले कर्ण आणि ऍडजसंट बाजू दॅट मीन्स लगतची बाजू भागिले कर्ण, बरोबर ना. सो सिमिलरली इफ वी रिप्रेझेंट द साइन थीटा इज नथिंग बट काय आहे या फायच्या अपोजिटची साइड, फाय झिरोच्या अपोजिट साइड कोणते, काय व्हॅल्यू आहे त्याची, हा इथं फाय आहे, याची अपोजिट बाजू कोणती, दिस वन. व्हॉट इज द मॅग्निट्यूड ऑर कशाचा बार आहे हा, सो इट इज नथिंग बट आय म्यू, राइट. सो साइन थीटा इज नथिंग बट आय म्यू डिवाइडेड बाय कर्णची व्हॅल्यू I0. अकॉर्डिंग टू दिस I mu it is equals to I0 sin of phi 0. Similarly IW it is equals to IW cos theta काय आहे किंवा cos phi 0 adjacent side that is IW divided by I0. According to this we got the value of IW it is equals to I0 cos of phi 0. You people know the value of cos of phi 0. You people know the value of I0. According to this, we are able to calculate the IW. Similarly, you people know the value of theta. From that theta or from that phi 0, you are able to calculate the sin of phi 0. And after sin of phi 0, we are able to calculate the I mu. So this is related to practical calculation. That is, we want to calculate the component, calculate the working component, or somewhat problem it may be also asked. That is, calculate the magnetizing component as well as working component. Okay, so this is related to, this one is the related to transformer on no load losses or transformer on no load. So it is useful while designing the transformer, and it is useful for a designer to understand the behavior of the transformer at a no load condition, right? Getting लक्षात आलं? Hello. Is there any doubt? Give me reply immediately because time is over now. Getting now?
Yes, sir.
Okay. In this way, we will conclude this today's lecture and we will stop. Here it is, one of the example is there, one problem is there. All of you take a screenshot and find the value of I0 and resulting power factor. Calculate the no load current I0 and the resulting power factor. Here it is, value is given. Value दिले बघा, IE ची दिलेले, IM ची दिलेले. So calculate the value of I0 and power factor. All of you take this problem and solve. Otherwise we will solve it in tomorrow's lecture. Okay, in this way we will conclude and we will stop here. Thank you.